Good day, ladies and gentlemen, and welcome. Not just to see what automation works can do for you, but what automation works can do for your future. Not just your future, but the future of your children, the future of the world, the future in general. That is not underestimated. Automation can do great and wonderful things. My name is Paul Odendal Streicher, Odendal by my comrades. Now then, this is my second year at Automation Works. I believe I could improve my points. That's why I'm doing this course over again. This is now our term 1, Mechanical Engineering of 2024. Now then, my project is a battle bot for a robot wars club. Sorry, a bit of a frog. Now then, my robot is named Nelsie, and you might be thinking, what a wonderful, cute name for a killer. Nelsie the wall grinder. And the reason why I picked Nelsie is because of the 3 lovely teachers before you. The N for Nick, the EL for Elmery, and the C for Mr. JC. And the reason why I did that is because they like to grind us in the classroom into dust. That's why I picked the wall grinder. Now then, the problem statement is children and adults are pent up with aggression. They have like this energy that they need to let out, but they can't because that would be illegal, depending on who you ask. Now then, and then there are people who are extremely intelligent, extremely smart with all these unique, great ideas, but are afraid on letting them out because of the fear of being labeled a nerd or a geek. So then, oh shucks, technical problems, there we are. Now then, my project description is a robot wars club where people, like-minded, smart, intelligent people can come together to create new and unique ideas and robots that they will pin against each other for the carnage just to let out that pent-up aggression. Because there's no laws against murdering robots yet. So it will be like a nice little club where people can come together, discuss, be among like-minded individuals, and just make wonders and miracles. That is not an exaggeration. We can make wonders and miracles. Now then, my robot, which I have designed, Nelsie, would be a representative of what is possible in the club. What you can make, what you can create. Nelsie is this first step into what what's possible for the club. Now then, project background or research. Firstly, I did a survey from the surrounding areas to ask, would you like a robot club? Would that be something you're interested in? Would children be interested? Do you think it would fit in the community? So far, I only got positive results. And then Wynand gave me a website link on a tutorial on how to build your robot, and they had these lovely pictures which Nelsie is heavily based off on, but had a few different modifications, like for example the saw was moved to the front for copyright reasons. Then I went to a lot of YouTubers and see how did they build their robots and how they fight with the robots. Then I went to the Robot Wars wiki, which is an international community of millions of countries with their own unique robot clubs around those different countries that came together to discuss their information, and this community set up the rules for Robot Wars. Now then, my design sketches. Here you can see how I started designing the sketch. All the parts that was put in, where everything goes and comes. And as you can see, there was a lot of wiping out and a lot of redrawing because, in my eyes, each robot is a unique concept. No matter how similar you build them, each one is a unique robot and therefore a first attempt. And with every last first attempt, there is experimenting, there is removing, there is adding, there is creating new things. These are my bill of materials. You might see that some of them do not have prices because I have found those items mostly on campus, which I am very grateful. I tried looking up their prices, but I have learned last year that there are multiple websites with different prices, and the problem with that is if I take the two highest price, then they will say you're getting scammed. If I took the too low of a price, then they say I am scamming the people. So I was feared of those type of questions. So rather picking the wrong price, I just left out the price and just notified you that I got the items here on campus. I did not steal them, if that's what you're thinking. I did ask. So here you can see all the items I used in the product, in LC, and the amount I used. And here's just a list of what was found on campus and what was not found on campus. My product structure model. Now this is how NELC is built up and what is controlled by NELC. Now that everything will be running through the ESP, which will be then connected to the weapons motor, which will then be connected to the main blade with a belt, which will control the speed and cause motion. Then we have the motor driver, which will be connected to the 4 motors, which will control the wheels and the forward and backwards motion. Then we have the main body with some screws holding everything together. The main body is a plastic layer where the screws could be drilled in or screwed in. Now then, 3D modeling screenshots. Now then, as you could see here, this is a massive mesh of different products and different bodies. Like I said, every robot is a first attempt with multiple takeouts, take-ins, see what works, figuring out what is the best point. And Nick pointed this out to me yesterday. He asked, why was the blade not in the middle? The reason that is that everything is so well planned and put in place correctly. If the blade was in the middle, I'll have to reposition everything, which will cause increase in space. And I was aiming for the right percentage between form and function, that Goldilocks zone between. Because if I went too far or too much on form or too much of production, it will cause the thing to collapse and crumble onto itself. So I went for that exact perfect middle Goldilocks zone with my design for both form and function to make sure that it does not take up enough space. If it took up too much space, then it will reduce speed. So everything is put in the nice exact Goldilocks zone to reduce size and therefore increase speed and weight and reduce weight. These were the the weapon blade motor clamps, which I as well designed and 3D printed. The motor will be then put into these and we'll then screw them in with the holes, and then we'll screw it down on the plate. These were the motor drive clamps and then the bearing sockets. How we then attach these items to the plate is through these 3D printed items. We have then 4 motor clamps and then 2 for bearing sockets. These are the arms to hold the blade in the air. We'll have then a left and a right. The bearings will be then put through here with the socket clamp, and then will be screwed down onto the plate. This is the blade clamp which I personally developed and designed. More on that later. Now then, modifications based on initial development. I had to replace the iron body. Originally it was made out of iron to increase strength, but replaced with plastic for increased speed and easier broken body removal. And to replace those body parts, And I had to replace the original blade, which I had in mind, with a smaller yet stronger blade, which I got from SSK. I'd like to thank the representative of SSK in assisting with that. Future developments. Now, this term was just mechanical, where we just focus on building the object, like adding the battery packs, 3D printing the clamps and all that such. Next term will be then the electrical wiring, where I will be adding code to Nelsie in order to make her move forward, backwards, and to attack. Now then, technical difficulties. Sorry. Now then, I had to figure out a way to create a clamp that holds the blade in the air. Was one of the many problems I had. At the same time, reduce the friction it had. I had to design a joint for the bearing, where the bearing a socket where the bearing could be put in, and then I had to design clamps for these wheels, which you saw in the previous slides, which I had to design for these motors. And then technical successes. I used then the bearings to reduce friction. I 3D printed, which you've seen in the other slides, the sockets and the motor clamps. Now then, lessons learned. I learned the rules of the robot wars and the robot wars community. And then here is my activity log, where you could see how I used my time. And mostly what I did was the poster. Here are the posters I used. I made 16 of them. These are just 4 examples, which I made as I used as a roadmap, where I made little notes on everything I needed to say. Acknowledgement. Now then, this is my poster. You can find here information about my problem statement, my motivation behind my design, contact information right here, a few pictures of Nelsie, me with the original saw, and a QR link that will send you to my website. Now then, ladies and gentlemen, thank you for coming. Any questions or comments, good or bad, is welcome.